All right, so here's 1.16, and this will be the last one for chapter 1. There is a 17, but it's based on some lab results, so we're not going to do that one, but it's very similar to this one anyways. So if you are in a class where you did that lab, then this should help you out. So this one is a little bit tricky. So we're given some experimental results here, and we're told to find the initial state that causes these results, basically. So it's saying that there is some initial state um, of something up and something down. Let's give it some um, scalar here and another one here. We basically just have to find out what A and B are. So we can start off by getting the inner product with the Z basis. We know that the result should be this one right here. Should be 1/2. So we get the bra of the up times our state here. So A up plus B down. And then we have our plus and our plus, and this is going to be a probability. All these here are probabilities here. So we need to do the probability over here. So we'll have an A, and then our plus and our minus cancel out, so we just have A squared. We know that A squared is going to equal 1/2. So A can equal 1/√2. So we'll put that right here. All right, and then so we have our minus right here. All right, so our minus and our plus drop out. Our B we take, we B squared, and for our down, we have also 1/2 here. So B can equal 1/√2. So we'll do that for now. B equals 1/√2. And then okay, we're done, right? We have A and B. And just plug those values in. And we'll go ahead and do that. So 1/√2, 1/√2. And then let's go ahead and test that out just to make sure that it works. So let's try in our x direction. So we have up in the x and our state here. And remember that up in the x is going to be 1/√2 up plus 1/√2 down. And then our state right here, which is the same thing. This should be a bra though. 1/√2 ket plus 1/√2 down. Okay, so then when we have our plus and our plus, again, we'll be taking the probability for this. We know that it's going to be 3/4. So we take our 1/√2 times 1/√2 is 1/2. And then we have 1/√2, 1/√2 again is 1/2. And we're going to square that. So 1/2 and 1/2 is 1 squared equals 1. That is not 3/4. So something went wrong here. So let's actually go backwards a little bit. And I'm taking a little bit longer to solve this one because I really want to highlight some fundamentals here. So let's go back to the original equation here and say A up plus B down. Okay, so we know this didn't work. And let's go and redo this one again. And we had our up. We did everything right up to this point. A up plus B down. All right, and then we took our up and our up, and we squared that. We knew that that had to equal 1/2. And then we said that A is going to equal 1/√2. Well, remember that A can be complex. So A squared is really A times A star. And if A is 1/√2, like we claimed, times the complex conjugate, which is still 1/√2, then that does indeed equal 1/2. I didn't lie to you there. Everything is fine there. This does work for this z direction. There's nothing wrong with this. But what could also equal 1/2? Well, what if instead of doing 1/√2, we did I/√2? And the complex conjugate would be negative I/√2. Well, I times negative I is going to cancel out and be 1 and also be 1/2. So there's more options than just 1/√2. I just happened to choose 1 over root 2, but I could have chosen anything. What I chose here, 1 over root 2, 1 over root 2, worked for the z direction, but it does not work for the x direction. So how do we find what will work for both? We need to make sure that whatever we choose still works for the z direction. So it's still, when you square it, it turns into 1/2. So we can't lose that part of it. But we need to also have the option that, or we need to also choose one that will also work for these other directions. So we kind of need to keep another variable in there that we can tweak, that we know will give us these results here, but could also be tweaked to give us some other results here. And in order to do that, so like this could be an option. We could try having an I over root 2 for the x direction and just see if that works. It wouldn't. And that would be a lot of like guess and check anyways. There's an infinite number of possibilities of things that we could use here. Another thing that we could use would be 1 over root 2 e to the I, anything really, e to the I x. Because then when you do 1 over root 2 e to the negative I x for the complex conjugate, this would become e to the 0, which is 1, and this would end up being 1/2 also. And that's what we're going to do. We're going to keep in this e to the I some variable, and then that variable is what we're going to need to find out in these other directions. So we could add it to both here. We could add, in our A, we could do e to the I, let's say alpha, and here e to the I phi, just so that we have two different variables, two things to tweak. We don't actually need to. We can do all the tweaking we need in one variable for all this. So we can choose one to be real, and typically the first value is chosen to be positive and real. So I'll keep the imaginary portion in B, and we'll keep that. So I know that was a long-winded way to get to this second part, but I think it was important. So instead of using 1 over root 2, let me just give myself some more space. A is still going to remain 1 over root 2. And now B, we're going to have this phase in here. So 1 over root 2 e to the I phi down. Okay, now we can see if that works. We know it's going to work for the z direction. Those are going to both give us 1/2, so that's fine. Now let's try the x, because that didn't work for us last time. And again, just like before, we're going to have the up bra for the x, so 1 over root 2 up plus 1 over root 2 down, times our state here, so 1 over root 2 up plus 1 over root 2 e to the I phi down. Okay, so for the up direction, we up and up, keep that. Again, we're going to be squaring this. So 1 over 2, 1 over root 2 times 1 over root 2. And then we'll keep our downs here. So we'll have plus 1 over 2 e to the I phi. And we're going to be squaring this. So there's going to be 1/2 plus 1/2 e to the negative I phi. Complex conjugate. All right, so then this is going to give us 1/4. This will give us plus 1/4 e to the negative I phi plus 1/4 e to the positive I phi, and plus 1/4 e to the I phi minus I phi, which is going to cancel out and be 0, so e to the 0, which means this will just cancel out and be 1. All right, so let's combine these terms here. So we have 1/2 plus 1/4, and I'll go ahead and pull out this 1/4 here. We'll have e to the negative I phi plus e to the positive I phi. And we can't combine these. We're not multiplying these together, so we can't do our e to the 0 trick to get rid of that. So what do we do with that? We have to pull out our Euler's formula trick again, which was e to the I x equals cosine x plus I sine x, or e to the negative I x equals cosine x minus I sine x. All right, so then we can replace these here. So keep our 1/2 plus 1/4. And then so e to the negative I phi is going to be cosine phi minus I sine phi. Okay, and then this one here plus cosine phi plus I sine phi. Well, that's helpful because now we can cancel out our imaginary terms here, negative I sine pi and positive I sine phi there. And now we're left with 2 cosine phi's. So I'll continue over here. We have I'll just rewrite it out again. 1/2 plus 1/4, 2 cosine phi. Okay, and we also know that this is going to equal, because remember, we're working with the up x, and the result for that was 3/4. We know that this is going to be equal to 3/4. All right, so let's go ahead and simplify this out a little bit. Okay, let's multiply everything by 2. So then we have 1 plus 1/2, 2 cosine phi plus 6/4. And then we will go ahead and pull out that 2. So then that's going to be 1 plus cosine phi equals 3/4. Not 3/4, 6/4. Okay, and then we'll subtract 1 from both sides. So cosine phi equals 6/4 minus 4/4 is going to be 2/4 or 1/2. All right, so then if we do our inverse cosine for 1/2, so we do 0.5. Inverse cosine is, where's the button? Right there. Okay, so I get 60 degrees. 60 degrees, I think I have my unit circle up over here, is, so 60 degrees would be pi over 3. And you could also just look at our unit circle to see what is 1/2 in x. If we do that, we see that we have pi over 3 or 5 pi over 3, because that would be, so phi is going to equal pi over 3 or 5 pi over 3. Because negative 60 degrees would be 5 pi over 3. Positive 60 degrees would be pi over 3. So there's 2 options for phi at this point. So I will keep the, actually there's more options than that obviously, because you'd have like 2 pi over 3 and all those multiples if you go around multiple times, but we'll keep these 2 for right now, because we also need to see what works for y. We haven't done y yet. We also haven't done x in the negative, but I think x in the negative will give us the same result. So we'll go ahead and just move on to y. So all we need to do is find out something that works for this phi. Everything else, our a's and b's, we have already. So let's do, we'll stay doing up, but we'll do it in the y. And our y is going to be, what was it? So our up for y was 1 over root 2 up plus I 1 over root 2 down, if I remember that correctly. So taking the bra, we're going to invert that, and that's going to become negative I. Okay, so same thing we did before. We're going to have 1/2 there. We're going to have a negative this time, negative I 1/2 e to the I phi. Okay, and we'll square this, and we need our complex conjugates, so 1/2 plus I 1/2 e to the negative I phi. Okay, and so we'll have 1/4 plus I 1, or this is going to be, what did I just do? plus I 1/4 e to the negative I phi minus I 1/4 the e to the positive I phi. And then we have negative I squared 1/4 e to the I phi minus I phi. That cancels out. So that cancels out. This cancels out and becomes plus. And then we've got 1/2. So we have a 1/4 and 1/4. So that's 1/2. We have a plus I 1/4. And then we have e to the negative I phi minus e to the positive I phi. Making sure I'm doing all this right. Okay. I erased my Euler's formula, but let's see if we can just remember that. So we have 1/2 plus I 1/4. And then so our negative I phi, we have cosine phi minus. It doesn't really matter because these are going to cancel out anyway. Oh, actually, yeah, I guess we'll see. I sine phi. And then we have a minus cosine phi plus I sine phi. And distribute that negative. So we'll have negative cosine minus I sine. So then at that point, we'll have 1/2 plus I 1/4. Let's see. So our cosine phi and negative cosine phi cancel. And we'll be left with negative 2I sine phi. All right. And let's go ahead and distribute this I. Let's see if I can do two steps at once here. The 1/4 and the I here. So we'll have a 1/2 negative 2. We're gonna have. I'll just write this out. We're gonna have 2 and 1/4 make 1/2. This is going to end up being negative 1/2 I squared sine phi. I think I did that right. Triple checking my work, make sure I didn't mess anything up. So this I squared will become a negative 1, so that would make that a positive. So change it to be that. And now we get our result, which should be positive, would be 0.067. Okay, so we will multiply everything by 2. So we have 1 plus sine phi equals, let's see what this times 2 is. 0.067 times 2 is 0.134. Let's subtract 1 from both sides. So sine phi equals this minus 1 equals negative 0.866. And take the inverse sign of that. Inverse sign of that is about negative 60 degrees. And let's go see what that is on the unit circle. So negative 60 degrees. Sine is, looks like it is 5 pi over 3, which works out because that was one of our options here. One of our options here was 5 pi over 3. And this here is 5 pi over 3. So there's other options for this, but this is the one that works. So that's going to be our phi. All right, so that means that we can replace our phi here with 5 pi over 3. And right here, give myself some room, 5 pi over 3. All right, and that should be it. You can do a quick check just to make sure. Let's do like x in the down direction should be 1/4. So let's do let's do down in the x direction. Our state here, and that's going to be x in the down direction is going to be 1 over root 2 up minus 1 over root 2 down. Then our state right here, 1 over root 2 up plus 1 over root 2 e to the I5 5 pi over 3. All right, so we have our 1/2 right here, 1/2, and we have minus 1/2 e to the I 5 pi over 3. All right, see what happens when we square this. So 1/2 minus 1/2 e to the I 5 pi over 3. So we have 1/4 minus 1/4 e to the I 5 pi over 3. Okay. Minus 1/4 e to the I. Oh, this should be negative I right here. Okay, so minus 1/4 e to the negative I 5 pi over 3. And then minus 1/4 e to the positive I 5 pi over 3. And then plus 1/4 e to the 0. Okay, so get rid of that. Combine our 1/4, so 1/2. We can pull out our negative 1/4, so minus 1/4 e to the negative I 5 pi over 3 plus e to the positive I 5 pi over 3. All right, so then we replace this with the Euler's formula, so 1/2 minus 1/4 cosine of 5 pi over 3 minus I sine 5 pi over 3 plus cosine 5 pi over 3 plus I sine 5 pi over 3. Fortunately, our imaginary terms cancel out, a positive and a negative. So then we have two of these. Cosine of 5 pi over 3, we already saw before, was 1/2. So we have two of those, 1/2 and 1/2 makes 1. So let's go over here. And we have 1/2 minus 1/4. We know we have a 1/2 plus 1/2. So that's just going to be 1, and that's going to cancel out. So then we have a 1/2 minus 1/4. So then we have a 2/4 minus 1/4 equals 1/4. And remember, this was down in the x direction, and we expected 1/4, and we got it. So that seems to check out. Whew, all right, so that was a little bit of a tricky one, but hopefully that all made sense, and hopefully that was helpful. So see you next time in chapter 2.